Assalamualaikum and hi, my name is Mohd Irfan bin Mohd Sanip. The title for my final year project is Remote Control System for High Volume Low Speed HVLS Fan for Suria Giant Fan Services Sdn Bhd. Here is the content of this video presentation. A little bit about Suria Giant Fan Company. Suria Giant Fan Services Sdn Bhd is one of the well-known company in Malaysia who develop and sell HVLS fan. HVLS fan stand for High Volume Low Speed Fan, which is fan that produce high volume of air with a low rotation speed. Suria Giant Fan Company use two types of motor, which is permanent magnet synchronous motor for Grande series and induction motor for Euro series. This remote control system is applying the same concept as regular remote control home ceiling fan. As you can see in this picture, this is the existing controller for Grande series HVLS fan. This project purpose is to change this existing controller to remote control system. The problem statement to run this project is because a lot of demand for HVLS fan that equipped with remote control system from customers of this company. The customer requested remote control system because sometimes they need to change the speed of the HVLS fan and they need to walk away, find the control box of the fan which sometimes located far away. Moreover, as we know, the HVLS fan with remote control system have not invented yet. The following are the result of a survey conducted on 10 Suria Giant fan customers. The chart show that 8 out of 10 participants agree for this project to be carried out. So this is why I need to develop this system. Many customers ask for the remote control system for HVLS fan so that they can on or off and change the speed of the fan just like the regular fan in their house. Suria Giant Fan Services Sdn Bhd is one of the well-known company that produce HVLS fan product brand Suria at Malaysia. So it is the priority of this company to meet the demand of their customers, especially in Malaysia. The opportunity of this project are to develop the first remote control for HVLS fan to fulfill the customer's demand, to commercialize the remote control, and to improve marketing quality and profitability for Suria Giant Fan Services Sdn Bhd. So here is the chart, shows the annual sales revenue for the past 7 years of Suria Giant Fan that prove the volume of Giant Fan sales is increased. Next is the objective of my project. The objective of this project are to design remote control system by using multiple fixed voltage regulator in Proteus 8 Professional to analyze the output voltage of existing HVLS fan controller with the remote control system to measure signal detection distance between transmitter and receiver of IR remote control module. Here is the flowchart of the methodology to complete this project. According to the flowchart shows, the project flow begin with literature review to get some ideas and knowledge about the development of remote control system. Data collection and problem verification are researched to get the ideology of this project. The system flow of the project has been identified using block diagram and flowchart to find out about the system clearly. Software development conducted to design the system based on the system flow studied before. For the software development, first I researched for the suitable component that can be used in this project and starting to develop the coding of the system based on the system flowchart that has been created. The system flow have two modes, which is off mode and on mode. For off mode, the system will cut off the signal for supplying voltage to the system, and on mode allow the signal in turn to the system. This is the coding for the system. The defined code is the code that appears when the button is pressed. As you can see, the case code is the coding for each button that I use. I set case code number 1 as on and off button. The system are allowing just one high signal produced at a time. For example, when button 2 is pressed, just pin number 4 is produced high signal and another is low. That is the overall of the coding system. This is the simulation circuit that I designed in Proteus 8 Professional. The switch acts as the signal output from the Arduino Uno. Components that used in this simulation are fixed voltage regulator, which is L7805, L7806, L7808, and L7810. Capacitor 10 microfarad, relay, resistor, and LED. So the output of this system is 5 volt, 6 volt, 8 volt, and 10 volt. Okay, now is the hardware development process. I assembled all the components that I want to use and connected all the components followed by the simulation that have been done before. Testing the circuit in the breadboard is important to avoid mistake before soldering all the components on the circuit. So here is the demo for the hardware. The table shows all the components that I use. Okay, now I'll turn on this prototype. I'll press 1 to on the system, and the initial voltage is 4.991, which is 5 volt. The speed number 1 is 6.0, which is 6 volt. Speed number 2, 7.99, which is 8 volt. And number 4, 10.06. And press 1 again to turn off. If we press speed number 1 and press 1 again to turn off. The 3, 4, and 1 again to turn off. So this is the final look of my project. Due to the pandemic that hit, I was unable to get across the state to do tests on the actual HVLS fan for its functionality. Here is some data that I get from the actual HVLS fan at the company. The data was collected on 12-feet fan, so here is some data collected using existing controller of HVLS fan. As you can see on the clip, the display on existing controller show the speed of the HVLS fan in percent. The speed and the armature voltage is directly proportional, which is 50% of speed, the voltage is 5 volt, 6 volt for 60% of speed, 7 volt for 70% of speed, and so on. To comply my objective number 2, I have compared the output voltage from the existing controller with my remote control system. We can see that my remote controller system produces almost the same output as the existing controller. Next is the analysis on IR remote controller module sensitivity. The test has been run at the distance from 0 meter to 10 meter to analyze the IR remote controller module. The chart shows the sensitivity of the remote controller is decreased when the distance is increased. The suitable distance using this IR remote controller module are compatible up until 7 meter. Otherwise, it is possible to trigger the system at 8 meter, but I need to press the button multiple times until it triggered. So this result is comply my last objective on doing this project. For the conclusion, this project is comply all the objectives that stated before. The constraint on doing this project is of course due to COVID-19 pandemic, which made me unable to conduct my project research on actual HVLS fan to analyze its functionality. For the future work for this system, I need to test the system on the HVLS fan. The remote controller also need to be upgraded so that the user can control the fan under the HVLS fan, which sometimes the fan is at 40 feet high, which around 13 meter. Also, for the circuit need to develop using PCB, as this project need to be commercialized to the company. Last, here is some Gantt chart of timeline for completing this project. Special thanks for my supervisor, which is Dr. Jurifa binti Malazi, that helped me a lot in completing project. I think that's all from me. Thanks for watching my video presentation.